Welcome back to my channel. In this part, we're going to talk about setting up equipment in Ekos and reviewing some of the Ekos tabs pertaining to equipment. I have to again apologize. This is my inexperience. I didn't realize how much information and how much recording there really would be in this subject. I decided to split this in part 4 into two parts. One part is setting up the equipment, and then the next part will be a real observation session using what we've learned. I also decided to make a separate bench testing video that will go over setting up equipment on the bench and testing it. And I have to apologize. There's a lot to cover here that I just didn't realize. So without further ado, let's get started. Okay, before we get started with K-stars, I want to add the Raspberry Pi server to an IP table in Linux. We use a etc host file to associate the IP address with the host name. So what we want to do is bring up a window or a terminal window and type in sudo nano and etc/hosts, return. At the end of that file, we're going to append the following information. This is my IP address of the Ekos Raspberry Pi. This is the name of my Ekos server and the IP associated with the server name. Your system will vary. It depends on how your network is and what the IP address is of the Raspberry Pi server. In my case, it's 192.168.15.60, and the name that I've chosen is ekos-server-test-wl. I chose this because this is an Ekos server, it's a test server, and the WL indicates it's wireless. Once you've added your server and the correct IP address for that server, do a Control-X, Y to save buffer, and a character return to write the file. Now, if you ping ekos-server-test-wl, it will be responding with the correct IP address, and you can see with the ping command here that the IP address and name is responding. Go ahead and do a Control-C, and that is how you associate the IP address with the host name for the Raspberry Pi on the desktop. All right, we're ready to start up K-stars. The equipment is connected up to the Raspberry Pi through a hub. Everything's been powered on. All the accessories are attached. So we're ready to start our K-stars session. Click the icon. This will bring up K-stars Planetarium program. Under Tools, press Tools and then pull down and select Ekos. We need to add a new profile. So instead of using simulators, we're going to pick our equipment profile. We do so by hitting the plus to add a profile and add the name of your system configuration. I'm going to be using Orion _ ASI 533 _ INT. Now the INT represents it's going to be using internal guiding. For the mode, we want remote, and this is where we add our Raspberry Pi host name. So it's ekos-server-test-wl. You don't need to worry about the port number, that is correct. We want to make sure that the internal guiding is set. We want to check the Indi Web Manager, and we use the Indi Web Manager on the remote device to start and stop Indi. So click on that. For the mount, you need to select your mount. In my case, it's going to be Ioptron IEQ 45 Pro. For the CCD, it's going to be a ZWO CCD. Now I actually have two ZWO cameras attached. One is the ASI 533 and the other one is the ASI 120. And I use that for the guider. Now you can go ahead and select that for the guider, but the next time you come back into the profile, you'll see a dash because only one driver is being referenced and it's accessing both devices. Under the focuser, if you have a focuser, pull down and select the focuser. In my case, it will be the smart focuser. I have a focuser attached to my telescope that emulates a smart focuser. I don't have a filter wheel and I don't need any other items to find here. Don't forget to select your primary telescope and your guide. If you don't have this, you could use the plus to add the devices. Once everything is set up and verified, hit save and then hit the start button. You should see the devices come online and they should be in a green condition for the connection. So here's the smart focuser. Everything looks good here. For my smart focuser, I do have to change this to 1600. For the, we don't have to worry about anything else. This is where connection is where you define and how you connect up to the device. Options are the various polling options for the device, and these all vary between focusers. For the IEQ mount, make sure it's connected, and that looks fine. For the cameras, they're connected, so we're all set to go. Now, one of the additional things I like to do under my primary camera is under controls, set up the gain, the white balance, the offset, and this looks fine for my setup here. So everything under Ekos looks good, and the next thing we're going to do is go over each of these tabs, and I'm going to go over and explain certain features of each of the tabs. One other thing I wanted to make a note, you could bring up the Indi control panel by selecting this icon. And one of the things I forgot to mention under the main camera, since I have a cooled camera, this is a nice way to monitor how much power is being used, and it's found here. Right now the cooler is not on and nothing is putting power to it because it's not on, but through the night, if you set your cooler at a certain voltage and you're having problems regulating the temperature, you might want to bring up the Indi control panel under the main control for your camera and look at how much cooling power is being used. If it's at 100% and your camera's not cooling down, there's a problem. Okay, let's go over each of these menus or tabs. The first tab is the Setup tab, and I also like to refer to it as the Summary tab. This provides a summary of the K-Star's Ekos operations. It will show you the status of the capture. It will normally have an image of a sequence taken, the latest sequence taken. It'll give you guide information and focuser information. This tab I normally use when I monitor a session and I want to just do a quick glance at what's going on through the night. The next tab is the scheduler. We'll cover this at another time, but this essentially sets up a scheduled session. You could set up Ekos to go through a totally automated session. It'll go to the target, it will align the target, it will focus, it will start the guiding process, and then it'll start the capture process. These are all setups controlled by this menu, and we'll do more on this later. We've already covered the Analyze tab. This is great for after reviewing a session to see how well you guided, for instance, if there are any issues. This is especially helpful if you have a scheduled session using the scheduler, you could have a quick glance of what went on during that session. This is your camera option. You'll notice here that the camera is set for the main camera. You can select the secondary camera. You could select the guide camera. And you'll notice that some of the features have changed when I selected that. I'm going to go bring it back into the main camera. Sometimes this is useful for troubleshooting. Normally you would leave this as your main camera, however. This is where you set up the cooler on your camera if you have one, if it's a cooled camera. This is where you set the temperature up, and if you check here, this enforces the temperature value. This sets the exposure. If you have a filter wheel defined, this is how you would set your filter. This is the count. The delay is used between exposures, so if you want to have a delay between exposures, you could set that up. This is the format. Normally with QHY and ZWO, you use the FITS. I've only used FITS under this, even under DLSR cameras. This is the type of image, whether it's a light, a bias, a dark, or a flat. This is where you'd set up the ISO if your camera supports it, and then also your gain and offset. I'm going to go ahead and add the gain. Sorry. And the offset. This could set up a frame, so you could change your frame size if you so desire. Normally for a main camera you wouldn't do that. Also your binning value, you could change your binning values. One thing to note under calibrate, if you have a flat file type that you're taking, this opens up this calibration button. If you click on the calibration button, you'll find that you have various different flat sources. Select the one that you're using. Also, flat duration, you could either set up with a manual exposure or based on AWU. And the AWU for my camera for a flat file is 6,000. It seems to work pretty well. But this varies, and you'll need to calculate or figure out what ADU value you should use. I'm going to change this back to light for now. Prefix. This is the name that's going to be prepended to the file. Normally this is set automatically, but sometimes it isn't, depending on what object and how you've captured the object. So just be aware of that. The target name, you might want to identify the target name as a different name, but keeping the target like M13. So sometimes I will put, M13-1 or M13-2 as the prefix. Postfix, I like to include the filter, the duration, and the timestamp to the images. It's just a good habit. That way, when you're processing the images, you could identify the order which the files or the pictures are taken. The directory, this is the directory where the files will be stored. In my case, I created K-Star's Astro Working. The save feature here, we want to save locally on the desktop. You have a choice of doing it locally, remotely, or both. Most Raspberry Pi users out there will have an SD card, and we don't want to write files off to the SD card. This tab down here for guide limits represents that if you're guiding and the deviation is greater than 2.0, it's not going to start the image until that settles down. In addition, if the guiding is over 3.5 arc seconds in deviation, it will abort the capture, and then it'll attempt to capture again. And this is useful, let's say, if you have a gust of wind and you your telescope moved or deviated from guiding, it will abort the capture and then restart. Sometimes if you lose the guide star, a same thing will happen. Under focusing limits, you could set up actual focusing limits. Now, if you use the autofocus IFR, this value automatically gets added after you've run your focusing routine. Autofocus at temperature deviations, this is useful. So if you want to change your focus after a certain amount of temperature change, you could do that. Or you could focus every X amount of minutes. I normally just set for refocus every 60 minutes, but it depends. It depends on how much it cools down through the night. So it just really depends on what you need to do, but the feature's there. This is your sequence queue. This takes all the information here and creates a job. And if you hit plus to the job, or if you add the job, it will add it to the sequence queue. You could also remove a job from the sequence queue by highlighting it and hitting minus, or you could restart the queue job again. Now we'll go in that when we're actually capturing some images here. This is a feature where you could do an instant capture or an instant preview. This will start looping, and this is useful if you're doing something, where that requires you to keep looping the camera as you're adjusting or something of that nature. I don't use live video, but this could be useful for, a live demonstration purpose or, comments or something of that nature. Tools down here, if you hit the dark frame library, it'll automatically set up dark frames based on exposures. I might do this later on. Script manager, I have not really used, so I'm going to leave this off of my discussion at this point. Let's do a quick demo. We have a 1 second exposure. I'm going to go ahead and click a preview. It does the exposure, and then it downloads the image, and you notice that it uses the FITS viewer to do that. Let's go ahead and create a sequence, and I'm going to do a 2 second sequence, or a 2 count sequence, and I'll add the sequence and I'll hit the start. This will start the sequence, and if I go over to the summary, you'll see that it captured the image and it finished capturing, and it's captured the next image and it displayed the next image. And it gives you the overall percentage of being completed. So you can see why this is somewhat useful. You could use your scroll wheel to make it larger or smaller. There's some other additional features here. You could have a bullseye. This is useful for calibration and centering objects and finders and so forth. This is an interesting option. We can't use it right now, but if you select that, it becomes red, and you could center the telescope on an object. So if you have, let's say, multiple galaxies and you want to center on a specific galaxy, you could click this icon, click on the object, and it'll center the telescope onto that object. Okay, let's go back to the camera. I think we've discussed most of that. Focuser, smart focusing. One of the things that we need to be aware of is you're going to have to play around with this. And I normally I took one evening and played around with the focuser just to see if I'm getting the V curves correctly, which processes work better than others for my situation and focuser. And this configuration works for me, but might not work for you. So just be aware of that. For the CCD, I use a 2x2 bin. That seems to give, it's of course less resolution, but provides a broader measuring method of looking at stars. I've set the gain for 180. That's useful because I'm only using a 4-second exposure. So I find 4 seconds is good enough time, and just adjust your gain to get good star images. We'll demonstrate that later. Auto select star and select the full field works for me. If I go over here, here's what I'm using for detection. I'm using SEP and one focus default. I'm using the linear algorithm, and here is where the various different algorithms are. I don't use an effect, and I use about 1.5% for tolerance. Kernel size, this is default to 5. Average over, now this is a good one to know. I never just take one image around here in Minnesota because skies are so terrible. I might start off with a good sky, a fair sky image of 2. If the sky is really poor, I might even do 3 frames. And basically, it will take 3 frames of 4 seconds and then average that over to come up with the HFR value. For the mechanics, it's very dependent on your focuser. This works the best for me, the initial step. And I'll demonstrate that as we go through tonight. For the mount, the only thing I'd like to say about the mount, I like to have travel limits turned on. For 15 degrees seems like it's a pretty good altitude limit for my area. The other thing you want to verify is just the scope setup and the guide scope setup. Also, you want to select since I have a German mount attached, I want to make sure that the flip occurs at HA of 0 degrees. After we polar align, this will be more meaningful as it will give you the countdown depending on how close you are to the meridian. The main features here are tracking and park and unpark. We use this through the polar alignment sequence. This is the align. This uses astrometric plate solving, and we'll go over this as we set up and align. Solver action's important. We normally either sync to a target or do nothing. For polar alignment, we do nothing. For normal operations, we slew to target. The other thing that's important is for camera usage. Normally under normal mode, we use the main camera and the primary scope, but for polar alignment, I normally use the guide scope and the guide camera. This sets up the exposure, the bin, and any other features here such as gain if you want to select that. I'm going to bump up the camera gain here to about 20, and that should give you a pretty good image. I'll show you more about this when we go through the polar alignment. And then finally, the guide tab. This is where you set up the guiding. One of the things I have to change here before I forget is the guide is set, my guiding rate is at 0.6. And that affects the proportional setting here. Also, I have set up the minimum and maximum pulses. The minimum pulses are 40 and the maximum is about 2,000. You may have to vary these depending on what your mount is and how your mount's working. Under options, this gives you some additional information. I'm going to let you play around with this, but you could remove the deck backlash and guide calibration if you want to. The main thing is the guide setup algorithm. I find that this works really well for me. So I use an SEP multi-star and one guide default. The other thing that I want to bring up is the dither. This is how you set the dithering between exposures or captures to dither your images. This value may vary depending on your guide scope and your camera and how much pixels you want to move in your main telescope. 3.0 seems to work pretty good for me. and this uses a random direction. PhD 2, I believe you could specify various different paths, such as spiral or whatever. I don't change anything else here, but I wanted to bring this up and show you that this is where you have additional guiding algorithms to set up. I have not used the GPG RA guider, but I haven't played around with this option at all. And I believe this might even be a newer feature. Alright, so that's it for the tabs. Now I'll start back up here when the sky is dark and we go through the polar alignment. I want to thank everybody for hanging in there. Thanks for watching. Please subscribe. And if you have any additional videos you want to see, please go ahead and add them to the comment. Part 4b will be coming up shortly. It probably will already be up there. I plan to release both the parts 1 and parts 2 of this Part 4 series immediately. So thank you again. Take care and clear skies.